So aside from being classified as a metal, non-metal, or semi-metal, elements in the periodic table are classified in terms of groups and periods. Periods are denoted by these numbers, and periods on the periodic table travel from left to right. So for example, hydrogen and helium both are in period 1. Period 2 would be all of the elements in the row labeled 2. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So periods go from left to right across the periodic table. What we're going to refer to more commonly in this course are elements that are in the same group. Groups on the periodic table go from top to bottom, and they are given a number and a letter. Sometimes those numbers are written in regular, 1, 2, 3. Sometimes they are given in Roman numerals. So you should feel comfortable with using both. So for example, elements, looking at the periodic table here, elements hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, cesium. All of these elements are in column 1A, so they are in group 1A. So groups are numbered at the top of each column. Now, these middle elements, the ones that have a number and a B associated with them, those are called transition metals. We'll talk about those later. But if we say that an element is in group 3A, we're talking about the elements in this group right here. These are group 3A elements. And again, we can either use Roman numerals or a number to designate group. So groups have a number and a letter associated with them. Some groups also have names associated with them. For example, all of these elements, which are in group 8A, they are termed collectively the noble gases. And noble gases are very stable. We'll talk about why that is later in the course. But when we say the noble gases, we are talking about elements in group 8A. So in the next slide, we'll show you some group names that you need to be familiar with. But before we go on to that, let's talk a little bit about finally what each square, which each house for an element tells us. So each element obviously has a name and a symbol. We talked about that in the previous video. Above the chemical symbol for an element in that square, in that box, is a number. In this periodic table, that number that is directly above the element symbol. On the periodic table that I have given you in a PDF form in this module, that atomic number is written actually more toward the upper left-hand corner. But regardless, if it's this number up top or this number that's right here, that is the atomic number. Atomic number, it's given sort of the variable Z. I finally found out it's based on Z because of the German word for atomic number. What you need to know is that the atomic number for an element is always, always, always equal to the number of protons in an element. And that makes sense because when you look at the periodic table, you see that each element has its own unique, its own different atomic number. Hydrogen's the only element on this periodic table that has an atomic number of 1. And we know from the previous video that elements are defined by their number of protons. So it makes sense that each element has its own unique atomic number, which on the periodic table is located either directly above the element or, as I said, on some periodic tables, it's slightly to the left. The number that is below the periodic table, or that is below the chemical symbol, is the atomic mass. The atomic mass, the units for atomic mass for an element are AMU, which stands for atomic mass units. Surprise, surprise. We'll talk more about atomic mass in a subsequent video on isotopes. What you guys need to know right now is that atomic mass for an element is always equal to the number of protons. I can write that, the number of protons plus the number of neutrons. And that makes sense because if you remember when we talked about what makes up an atom, the majority of the mass of an atom is in the nucleus, and what two subatomic particles are in the nucleus? That's right, protons and neutrons. So it makes sense that the number of protons and number of neutrons, when you add them together, gives you the atomic mass. Now, why some of these atomic masses are not whole numbers, we will talk about in the isotope video. Right now, know that atomic number, this number up top, is equal to the number of protons. Atomic mass is equal to the number of protons and neutrons. Elements can be talked about in terms of their period and in terms of their group number. And we said that some particular groups have names that are associated with them, and I have listed those right here. So those are all important points about the modern periodic table. In the next video, we're going to talk about how to use the periodic table to determine numbers of protons, neutrons, and electrons for an element, and introduce the concept of isotopes.